Hello! In this video, what I'd like to do is introduce you to arguably my favorite amino acid. Now, my favorite amino acid is the amino acid aspartic acid. Aspartic acid is one of two negatively charged amino acids. Aspartic acid is identified with the three-letter code A, S, P, and the single letter code D. Now, aspartic acid was discovered in 1827 by French scientists. And aspartic acid has a structure that looks like this. Our N termini goes to our alpha carbon. Alpha carbon goes to our C termini, our carboxylic acid. I'm drawing this amino acid at a pH of 1. We have hydrogen off of our alpha carbon, then our our N termini has 3 hydrogens, and that's going to be positively charged at a low pH. The R group for aspartic acid looks very similar to the R group of asparagine. We have a beta carbon with 2 hydrogens coming off of it, and then we have a carboxylic acid. Hence the name aspartic acid. Okay, now the 3 groups that we have off of our alpha carbon, our C terminal, or our C termini, has a pKa of approximately 1.99. The N termini has a pKa of approximately 9.90, and our R group has a pKa of approximately 3.90. So this is considered a triprotic amino acid. This is also considered a polar negatively charged amino acid. Now, the reason for that is based on, well, what are those pKa's and what is the charge of this amino acid? At a pH of below 1.99, so I'm going to write it as at below 1.99, this amino acid is going to have an overall charge of 1 plus. Above 1.99, well, that means that the C termini is going to be deprotonated. So there's going to be a negative charge there, which means you have a positive charge and a negative charge. They'll effectively cancel out, whereas your R group is going to remain neutral. So this can be plus 1. It could also be 0. At a pH of above 3.90, that means the C termini and the R group are both going to be deprotonated. So that's 2 negative charges where your N termini remains positively charged. So that means that this molecule at a pH of above 3.90 is going to have a -1 charge. Now, finally, at a pH of above 9.90, well, that means that all of these groups are going to be deprotonated. The carboxylic acids will both be negatively charged, whereas the N termini is going to have no charge whatsoever. Rather than being NH3 plus, it's going to be NH2 with a lone pair of electrons. So no charge whatsoever, but that does mean that the molecule as a whole has a -2 charge. So aspartic acid could be +1, 0, -1, or -2, depending on the environment in which it's in. Well, I hope this is helpful in getting to know the amino acid aspartic acid, my personal favorite amino acid. And I hope this was helpful in your journey of learning your amino acids. Well, have a good one.